So today we're going to talk about artificial intelligence in first-person shooter games. But first, what is artificial intelligence? Roughly speaking, it's the field of computer science dealing with creating programs whose actions or behavior adapt to address the input, such as a problem. For example, a chess-playing program chooses moves based on the moves of its opponents, so its behavior depends on the behavior of the opponent.
Have you ever wondered how the computer opponents in games such as Counter-Strike and Call of Duty make the game challenging for you?
The artificial intelligence in first-person shooter games can be broken down into 4 layers: animation, movement, combat, and behavior.
The animation layer is responsible for controlling the body of the NPC. It defines sequences of animation like walking, running, etc. First step is deciding which motions to use, and various 3D modeling software such as Maya can be used to design sequences such as a sequence of walking. For more realistic motions, we use motion capture. You might wonder, why do we need AI in animation? AI is required to select the right animation for the right time. For example, we do not want the NPC to execute the sequence of walking while it is sitting.
The next layer is the movement layer, which involves coordinating the actions of the NPCs so that they can navigate the video game environment. Examples of actions might include following other agents, avoiding obstacles, or planting a bomb and escaping. Basic task in coordinating movement involves finding the shortest path from one point to another. To achieve this, the environment is broken down into a set of points and edges connecting them. Each edge is assigned a number called a weight to represent the distance between the points. Here we demonstrate an artificial intelligence algorithm called A-star search over a set of points representing cities in South Texas. Using this map, we would like to find a route from Dallas to Houston. The map contains both driving distances between cities directly connected by a road and also an estimate labeled in green for the distance to Houston. First, we start at Dallas and note that we can directly reach both College Station and Austin. Via College Station, the driving distance is a total of 172 actual plus 60 estimated. Via Austin, it's a total of 176 actual plus 120 estimated. So our best bet at finding the shortest route is via College Station. Exploring it on the map, we find that we can reach both Austin and Houston. We can update the driving distance via College Station to a total of 172 plus 99. We don't need to update the driving distance to Austin from Dallas via College Station, since that shortest route is still 176. Since the green estimates are smaller than their actual values, we can only find a route longer than 296 to Houston by exploring Austin on the map. So the shortest route must be via College Station. Thus, A-star search makes use of both actual distances and estimates to quickly find shortest paths. More complex variations of this algorithm can be used in environments that change over time.
The third layer is the combat layer, which is responsible for assessing the situation intelligently. The AI is used to select and execute appropriate tactics such as ambush, flee, hide, etc. In many games, NPC is allowed to cheat. For example, being able to access player's position even though the NPC cannot see the player, or being able to see in the dark without any sort of night vision.
The final layer is the behavior layer, which determines the overall goals of the system. Artificial intelligence is used in this layer to decide when to transition between different behaviors such as patrolling, combat, and searching.
Finally, we would like to talk about artificial stupidity. Game makers want players to have fun by winning the game. If the AI is really smart, the player will find the game very difficult.
The NPC can be made stupid in many ways. For example, waiting for a player to shoot before shooting, warning the player before attacking, or even having a really bad shot. So, the next time you play your favorite first-person shooter game, keep in mind that you're actually playing against a complex and intelligent computer program. Thanks for watching, that's all.